In this video, we're going to learn how to choose a pivot. In the very last video, we had a pivot given, and we had to make that a 1 and everything else in the column 0, but normally we find our own pivot. So that's what video 23 is about. You locate the most negative indicator. If there's two such indicators, choose the one further to the left, because you would like to get into the actual variables that are being used. Form the necessary quotients to find the pivot. Now quotients, what that refers to, like in the previous one, this is my most negative right here. So normally what we do is we put an arrow indicating the most negative. Okay. And our necessary quotients, what that means is I come right here and I'm going to do 60 divided by 1. Let's see, I've got to go into this. So I would do 60 divided by 1. The next row, I would do 100 divided by 2. The next row, I would be doing 200 divided by 3. Okay? That's what it means by necessary quotients. This would equal 60. This would equal 50. This would equal, let's see, that would be 60 something. Okay? So let me put that right there. Now, you do your necessary quotients. Disregard any quotients with a 0 or a negative number in the denominator. Disregard means you kick it out. The smallest non-negative quotient gives the location of the pivot. So in this particular problem, my arrow, I need an arrow. My arrow would be coming in right here. So if you'll notice where my two arrows meet, that's where my pivot is. Why we choose the smallest is because of the basic feasible solution. When I go through the Gauss-Jordan procedure on this, if I use one that's larger, I actually end up with a negative over here, which is a no-no. Alright, so let's keep going. Smallest non-negative quotient gives the location of the pivot. If all quotients must be disregarded, no maximum solution exists. If two quotients are both equal in smallest, choose the pivot in the row nearest the top of the matrix. It really doesn't matter. This just gives you a way to attack the problem. Make the pivot a 1 and then use row operations to change all of the numbers in the pivot column to 0 by adding a suitable multiple of the pivot row. That's our Gauss-Jordan procedure there. If all the indicators, now this is talking about the bottom row, are all positive or 0, this is the final tableau. Okay? If not, we got to go back to step 1 and repeat the process until the tableau with no negative indicators is obtained. All that means, if I end up with a negative in the bottom row, I have a better solution. There's a better solution out there for me to get. Read the solution from the final tableau. Remember, the solution cannot contain a negative, so all values, including the slack variables, must be greater than or equal to 0. So the initial simplex tableau of a linear programming problem is given. So we're going to follow this procedure and solve it. So first thing, locate most negative number. So my most negative number is going to be right here. I'm going to go do my necessary quotients. I'm going to do 50 divided by 1. $40 divided by 3 and 80 divided by 5. So if you have to, let's see, 40 divided by 3, 80 divided by 5. The smallest is the 40 divided by 3, so my arrow is going to come in at that point. So this is my pivot right there. So let me insert a shape, because you really need to show where your pivot is and what your pivot is, because that way you can concentrate on it. Hold on, I'll make it appear here in just a second. So there's my pivot. So now what I need you to do is write down the steps that's necessary to make this position a 1 and everything else in that column a 0. So pause me, because I'm going to go ahead and show, because this is stuff you should already know how to do. Okay? So I'm going to multiply row 2 by 1/3 to get my new row 2. I'm going to multiply row 2 by -1, add it to row 1 to get my new row 1. I'm going to multiply -5 times row 2, add to row 3 to get my new row 3, and then a +5 times row 2, add to row 4 to get my new row 4. Those would be my steps. So I need you to do the procedure to your matrix and see if you come up with the next matrix here. Okay? My new matrix that you should have come up with is this one right here. Now if I read the solution right now, x sub 1 would be 0, x sub 2 is 0, x sub 3 would be 40 over 3, s sub 1 would be 110 over 3, s sub 2 would be 0, s sub 3 would be 40 over 3, and my z would be 200 over 3. Okay? So, hopefully you ended up with that. Let me see, if all the indicators referring to bottom row are all positive or 0, this is the final tableau. Since I see a negative, that means this is not the final tableau, so I need to start this procedure over again with my new matrix. So my most negative would be right here at -4/3. Go do your necessary quotients. So I'm going to have 110 over 3 divided by 5/3. 40/3 divided by 1/3, and another 40/3 divided by 1/3. Now guys, do use parentheses on this. Your calculator gets a little bit weird. Let me do the first one at least. Let me do 110 divided by 3 divide by 5 divided by 3. That would be a 22. Look what happens if I do not use parentheses. Whoops, I did times. Sorry about that. I'll go back in and make it division. I'm still going to have an issue. And that ain't 22. You need parentheses around this. Please be careful. Now check out the other ones. Let's see, if you do 40/3 divided by 1/3, I think you end up with 40. So my smallest one would be the first one. So this arrow, that arrow meet right here. So that's my new pivot. Let me make a bigger circle. Oops. Okay. So write down your steps. Got to make this position a 1 and use it to make everything else in that column 0. Let's see if you remember how to do the steps. So pause me and see if you end up with what I've got under here. And hopefully you did. Now, if you did, now apply it to your matrix and see if you end up with this new matrix. Now, x sub 1 is not a Gauss-Jordan column, so it would equal 0. X sub 2 would equal 22. X sub 3 would equal 6. S sub 1 and S sub 2 would both be 0. S sub 3 would be 6. And my z value, my maximum, would be 96. It says this is the final tableau because, notice in the bottom row, everything is greater than or equal to 0. So that's it for this particular video. Thank you.